All right, so we are going to do an example of an OR inequality, very commonly called an OR inequality, but more mathematically accurately called a union or disjunction inequality. So we're going to go through how to solve and graph. Now, I'm going to be kind of brief on solving because you've gone over solving inequalities, you've gone over solving equations. It follows the same exact rules. Of properties of equality, how to solve for the variable. It's the same thing. You just got to be careful of signs when there is division or multiplication by a negative. But other than that, these are kind of the same rules that we've been following all along. So I got, and since a lot of compound inequalities are simply just the combination of two separate inequalities, you're just solving two inequalities and applying the solutions together. So it's not really anything new. So if you view it as something new, you're going to lack confidence. But if you view it as connected to solving equations and solving single inequalities, you're going to be fine. You just got to think of this as something that you already know, because it kind of is. So in the first part of my inequality, I am solving for h, and I have variables on both sides of my inequality. So same trick, move the smaller one. Smaller one is negative 2h. The only way to zero that out is to add 2h to both sides, combining my like terms, making sure I'm adding it to the variable and not the constant. This lets me have, bring down negative 7, greater than h plus 2h is 3h, bring down that positive 5. Now I'm just going to subtract this 5 from both sides because that's following my order of operations, attacking the addition first because now I have a two-stepper. Negative 7 minus 5 is negative 12. Negative 12 is greater than 3h. 3 times h, I need to get the h, I need to solve for h. The only way to do that is to divide both sides by 3, as that will turn this over here into 1, because 3 divided by 3 is 1, and effectively cancel it out. Negative 12 divided by 3 is negative 4. So negative 4 is greater than h. Now be careful with that when you're graphing it, because h is smaller than negative 4. So if I'm really making this graphable, I should have h is less than negative 4. I see a lot of mistakes with this one where it will be inappropriately graphed because people see the greater than, and that's what they hitch onto, because as humans, we do like to find and stick with patterns, but make sure you're sticking with the correct patterns. So the pattern here is noticing that the variable is less than, in this case, smaller than our target number. So now I'm dealing with my other inequality, which is 1/4 times h plus 8 is greater than or equal to 9. Now, be careful with this, or the scary part of this is we see a fraction. But that is easy enough to deal with if we remember that fractions are division. So 1/4 is indicating that we are applying a division by 4 here. So how do I reverse division by 4? I multiply everything by 4. So if I do this, I can get away with not actually changing the values of the equation. Now, you got to be careful when you are distributing to try to eliminate a fraction that is already outside of another distribution. You don't have to distribute this 4 outside to the h and the 8 because it's already going to take the thing that's multiplying them, the 1/4. So all I have to distribute to in this case is the 1/4 and our 9 over here. And get my pen to work, because that 1/4 was already distributing. So if I'm trying to knock out this fraction, I'm thinking, okay, 4 times 1/4, that gives me, so we'll go through this step by step so you can see it. 4 over 4, h plus 8. Now I do have to multiply that 4 times 9, so that's going to give me 36. Now, 4 over 4, that's 1. 4 divided by 4 is simply 1. 1 times h plus 8 is greater than or equal to 36. We don't need that one because multiplying anything by 1 does not change the value. So we are just going to keep h plus 8. So we were able to get rid of this distribution by doing another one. So I have h plus 8 is greater than 36, so this leaves me with one more step to do before I'm done. And I'm going to use my subtraction property of equality to zero out that left side, get rid of that 8, make it move, and I'm going to get h is greater than or equal to 28. So now all I have to do is graph it. Now remember, or both of my possibilities are correct. I do not have to, they do not, when I'm talking about what my solution set is, it doesn't need to satisfy both things. It needs to satisfy one or the other. It needs to be either less than -4 or greater than or equal to 28. So I am graphing both of these solutions essentially on the same number line. So when I'm doing a compound inequality, a lot of times I like to just kind of, if I have a negative and a positive, I like to indicate where 0 would be, but we're not too worried about it being accurate as far as distance on the number line. I mean, you do want to make sure that your positives are on the right side and your negatives are on the left side, and making sure you're labeling things correctly, but the biggest thing is making sure you're graphing correctly. So less than -4, that's an open circle, less than points to the left, and you can see what the issue would have been if I had tried to get this greater than, it would not have been graphed properly. Greater than or equal to 28, closed circle, greater than or equal to goes to the right. And there you have solved and graphed an inequality, a compound inequality that is a disjunction union / union using that term or.